How many of you guys really know what a black hole is? Well, a black hole is simply an area in space with an extreme density and gravitational pull so strong that not even light can escape it. Oh, wait, wrong. So there have been many recent discoveries regarding black holes, leading to newfound puzzle pieces about the universe. Every day we wake up, we go to school or work, then we go home, we sleep, and then wake up a new day. But we never really think about the fact that we are just a minuscule part of an infinitely expanding universe. So as residents of this universe, it is important to know what is beyond the atmosphere of the planet we call Earth. So what is a black hole? So first, I will talk about how black holes were discovered. Then I will talk about the 3 different types of black holes. And then I will talk about the structure of a black hole and some theories about them. So first, how were black holes theorized? So black holes were first theorized by Albert Einstein. According to Albert Einstein developed and published the general theory of relativity, and in 1915. And according to Nola Taylor-Reid, contributor to Space.com, and author of Einstein's general theory of relativity, was Einstein's new way to describe gravity. So when we think of gravity or gravitational pull, a lot of us know about a law created by Isaac Newton, or was discovered by Isaac Newton, that physical objects with a greater mass attract physical objects with a smaller mass, pulling them in. But what Einstein's theory states is that objects aren't really being pulled in by gravity. It's actually a push from space. And that massive objects greater massive objects have the ability to distort space-time. And according to Einstein, according to this theory, he had the theory that space was actually a fabric. So, like Earth, for example, space would be like a blanket over Earth. So it would actually just wrap around Earth instead of Earth just being in space. So how was the idea obtained? Oh, this is an image of, I guess, the fabric of space and Earth. Okay, so how is the idea obtained from the general theory of relativity? So I stated that massive objects have the ability to distort space-time. So the more massive an object, the greater its effect will be. The first black hole that was discovered was Cygnus X1, which is actually an image over here. That's just an idea of what it looked like. But according to an astronomer for NASA, or an astrophysicist for NASA, Paul Butterworth, he said that Cygnus X1 had a companion star, and they noticed that this companion star was becoming closer to this Cygnus X1. So then they deemed it as a black hole. So the term black hole was coined by John Wheeler in 1969. So now that I have explained more about the general theory of relativity, I will now explain the 3 different types of black holes and how they are formed. So in order for a black hole to be formed, a star has to collapse on itself. And in order for a star to collapse on itself, it has to die, but it also has to be 3 times the mass of the sun. So if it isn't 3 times the mass of the sun, it won't be able to collapse into itself, and it could just become a neutron star. So there are three different types of black holes. There are stellar black holes, which are basically smaller black holes, but they're extremely dense, and they could compact mass in an area as small as a city. And if you were to fall into these kinds of black holes, you would experience what scientists call spaghettification. You'd just become like spaghetti. And there are also supermassive black holes, which are the giants of the universe. According to Red, these black holes are billions of times the mass of the sun, and they may be the result of hundreds or thousands of many black holes merging together or a collapse of a stellar cluster. Then there are intermediate black holes. Intermediate black holes are like medium-sized black holes, and scientists originally thought that there were only big black holes or small black holes, but according to NASA, recent evidence from Chandra and XMM Newton and Hubble strengthens the case that these mid-sized black holes do exist. Okay. So the structure of a black hole. So the structure, there are 5 different parts of a black hole. There's the event horizon, which is this area. This part of the black hole is like the space around the black hole. Then there's the singularity, which is the core of the black hole, and the radius, or the Schwarzschild radius, is this radius, or the radius, this part, so half of that. And the accretion disk, which is material that is spiraling underneath the black hole, and space-time. Then the ergosphere, which is just the space around the black hole. So a lot of things, so a lot of people believe that black holes suck things in, or pull things in, but objects actually just fall into black holes. They could also slow down time, so the closer you get to the black hole, the slower time goes. And our Milky Way actually has a giant black hole in its center, and a lot of other other galaxies also have black holes in their centers. And for those of you wondering, the sun cannot become a black hole, because in order for it to become a black hole, it would have to be 3 times the size, or 3 times its mass. So no matter what you see in sci-fi movies, it just isn't possible. Let's see. So we're all a part of this universe, and a lot of the time we forget that. It is an important thing to remember, though. Black holes are just one little piece of a much bigger puzzle.